we were doing differentiation. Today we are going to start next topic of differentiation, that is higher order derivatives. Higher order derivatives. अभी तक जो हमने क्वेश्चन किए उसमें हम फर्स्ट ऑर्डर डेरिवेटिव की वैल्यू निकाल रहे थे dy अपॉन dx, हायर ऑर्डर डेरिवेटिव ऑफ डिग्री 2, 3 एंड सो ऑन. हमें सेकेंड ऑर्डर का डेरिवेटिव, थर्ड ऑर्डर डेरिवेटिव, फोर्थ, फिफ्थ एंड सो ऑन हायर ऑर्डर डेरिवेटिव्स निकालने हैं. सो लेट अस स्टार्ट विद द क्वेश्चन 1. राइट डाउन द स्टेटमेंट. If y is equals to sine inverse of x, then show that to prove d square y upon dx square x upon 1 minus x square power 3 by 2. Now we know that we are given this differentiate with respect to x. What we get? dy upon dx, derivative of sine inverse x, 1 upon square root of 1 minus x square. We can write it as like this, power 1 by 2. When it goes in the numerator, sign of the power will change. Now we have to find the second order derivative. So again differentiate with respect to x. Derivative of this dy upon dx, derivative of this term x power n x power n minus 1, since x is this term, so derivative of 1 minus x square. Now here we get d square y upon dx square minus 1 by 2, 1 plus 1 by 2, 3 by 2. So we can write it as 1 minus x square power 3 by 2, because here the power is negative. When this term goes in the denominator, sign of the power will change. Derivative of 1 is 0, x square is 2x. Minus minus plus 2 will get cancelled. So we have left with x upon 1 minus x square power 3 by 2. This is what we want to prove. Next one is, if y is equals to a cos of nx plus b sin of nx, prove that d square y upon dx square plus n square y equal to 0. Differentiate this with respect to x. What we get? dy upon dx, a is constant, derivative of cos is minus sin. nx, derivative of nx is n. Clear? Plus b, derivative of sin is cos, derivative of nx is n. Again differentiate with respect to x. d square y upon dx square minus na, derivative of sin is cos of nx, derivative of nx is n, so n into n, n square, plus nb, derivative of cos is minus sin nx, derivative of nx is n, so n square here, minus n square common, a cos of nx plus b sin of nx. A cos nx plus b sin nx. This is the value of y. Use equation 1 here. So minus n square y. Use 1. So what we get? d square y upon dx square plus n square y equals to 0. Note it down. Now next one is, Now the next one is if y is equals to a e power mx plus b e power nx, then show that d square y upon dx square minus m plus n dy upon dx plus m and y equal to 0. Differentiate with respect to x. What we get? dy upon dx, a e power x, derivative of that is e power x. Instead of x we have mx here, so derivative of mx is m, plus b e power nx, derivative of nx is n. Now again differentiate with respect to x. d square y upon dx square m a e power mx, derivative of mx is m, so m square, b e power nx, so n square here. Now we want to prove this. So take left hand side, d square y upon dx square minus m plus n into dy upon dx plus m and y. Second derivative value we have m square e plus n square b e power nx plus m plus n into this m plus n into m a e mx plus n b e nx plus m n y is a e mx plus b e nx. Now solve this value. What we get? M square a e mx plus n square b e power nx, m into m square a e mx plus m into n b e nx plus m into n a e mx plus n square. Here we have negative sign, so all the signs will change. Minus 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 n square b e nx plus mn a e nx plus mn b e nx. mn a e nx, n square and m square, so that is equal to 0. This is what we want to prove. Now the next one is if y is equals to a into cos of log x plus b into sine of log of x, prove that x square d square y upon dx square plus x dy upon dx plus y equal to 0. Differentiate with respect to x. What we get? dy upon dx, a derivative of cos is minus sine. Instead of x we have log x here, so derivative of log x is 1 upon x. Derivative of sine is cos, derivative of log of x is 1 upon x. Clear? Take the x as LCM, so we get x dy upon dx minus a sine log of x plus b cos log of x. Now again differentiate with respect to x. Differentiate with respect to x. Here we will apply u into v rule. First function as it is, derivative of second plus second as it is, derivative of x is 1 minus a derivative of sine is cos of log x, derivative of log of x is 1 upon x, derivative of cos is minus sine log of x, and derivative of log x is x. Now this x goes on left hand side. By taking LCM we get x dy upon dx. Take negative common, a cos log of x plus b sin log of x. So what we get? A cos log of x plus b sin log of x. This is value of y. So we get x square dy upon dx square plus x dy upon dx plus y equal to 0. This is what we want to prove. Note it down. Next one is, if y is equals to tan x plus sec of x, y is equals to tan x plus sec of x, prove that d square y upon dx square is equals to cos of x upon 1 minus sin x whole square. Now differentiate with respect to x. What we get? Derivative of y. Derivative of tan x is sec square x. And derivative of sec of x is sec x tan x. Clear? We can write sec square as 1 upon cos square. Tan as sin upon cos. Here also cos square x. Take the LCM. 1 plus sin x. Instead of cos square x, we use the identity here. 1 minus sin square x. We can write it as a square minus b square. A plus b into a minus b. 1 plus sin x will get cancelled. So we have left with 1 upon 1 minus sin x. Now we want to find the second order derivative. So differentiate with respect to x. What we get? Derivative of dy upon dx is d square y upon dx square. 1 upon 1 minus sin x. 1 minus sin x whole square. U upon v. V square u dash. Derivative of 1 is 0 into v minus u into v dash. Derivative of 1 is 0. Sin is cos of x. So we are left with minus minus plus cos of x upon 1 minus sin x whole square. Clear? If y is equals to tan x, to prove y2 is equals to 2y into y1, we can write second order derivative as y2 y double dash. y1 is first order derivative. We can write it as like this, or dy upon dx. So we want to prove second order derivative is equals to this. Y is equals to tan x. Differentiate with respect to x. Derivative of tan is sec square x. Now again differentiate with respect to x. D square y upon dx square. Derivative of sec square 2 sec x. Then derivative of sec x. Derivative of sec x is sec x tan x. Clear? 2 sec x is 1 upon cos x. 1 upon cos x tan x. Here we want y into 2 times y1. So we can write it as 2 sec square x. Sec square x is the value of y1. Let this equation as 1, this as 2. We can write it as y2. 2 into dy upon dx into y. Use 1 and 2. Clear? Sec square x is value of first derivative, tan x is value of y. So we can write it as 2y. Instead So y2 is equals to 2 into y into y1. Next one is, if y is equals to x into, if y is equals to x into log of x upon a plus bx, prove that x cube into d square y upon dx square, x dy upon dx minus y whole square. First we can write it as y upon x, this x goes on left hand side, log a upon b, we can write it as log of a minus log of b. Clear? Now differentiate with respect to x. U upon v rule here, v square u dash derivative of y into v minus v dash derivative of x is 1. U as it is 1 into y, derivative of log of x, log of this term, derivative of a is 0, bx is b. Is it clear up to here? So what we get, x dy upon dx minus y, this x square goes here, x square upon x minus bx square upon a plus bx. Now in the next step, take the LCM here, x dy upon dx minus y, 1 upon x minus 1 upon a plus bx b. Take the LCM, x into a plus bx, a plus bx minus bx. This will get cancelled, 1x will get cancelled, so we are left with ax upon a plus bx. Clear? Ax upon a plus bx. Now again differentiate with respect to x. U into v rule here, first derivative of second plus second derivative of x is 1 minus derivative of y, u upon v rule here, v square u dash derivative of ax into v minus u into v dash derivative of a is 0 and bx is b. So this term will get cancelled, x d square y upon dx square, a square plus abx minus abx upon a plus bx whole square. So we are left with this term, x d square y upon dx square, a square upon a plus bx whole square. Now we want to prove this term, so multiply both sides by x square. Multiply both sides by x square, x cube, d square y upon dx square, a square x square upon a plus bx whole square. Here we want x dy upon dx minus y whole square. We can write this term as ax upon a plus bx whole square. Now we have to find the value of this term. X dy upon dx minus y. Let it as equation 1. Use 1 here, x dy upon dx minus y whole square using 1. So this is what we want to prove. bracket log of y log of x power m log of x. Now differentiate with respect to x. Derivative of log of y 1 upon y dy upon dx. First derivative of second plus second derivative of first. Now we get 1 upon y dy upon dx 1 plus log of x. Clear? We can write it as dy upon dx y into 1 plus log of x. Now differentiate with respect to x. Sorry. D square y upon dx square. First as it is. Derivative of second. 1 is 0. Log x is 1 upon x. Second as it is. Derivative of first.